Nearly a year has passed since the James Webb Space Telescope transmitted its initial image following its complete activation on July 11, 2022. Using this remarkable space observatory, we now have the most precise images taken of Neptune, Uranus, Saturn, and even its moon Titan. But we cannot let go of our desire to look further and deeper to find out what lies beyond the known universe. With the JWST's powerful infrared capabilities, we can now examine the birth and progression of ancient early galaxies by looking back in time. This journey has already begun, so prepare to witness the latest images from JWST Observatory, including the first ever image taken of the most remote galaxy we have ever detected. Welcome to Adventures in Space. The James Webb Space Telescope is a technologically advanced instrument that is highly regarded as a significant accomplishment for scientists and space explorers. Using its capabilities, we can embark on a journey to the beginning of time, starting with the initial deep field image captured by the telescope. Although you may have already seen this image, you might not have realized that it depicts the farthest reach of human observation into the universe. When compared to an image taken by the Hubble Space Telescope, it becomes evident how much more detailed and precise the JWST's views of star clusters in the early universe are. The area of expertise of the Webb telescope is capturing images in the infrared spectrum of the light, like this stunning photo of Carina Nebula, for instance. It is incomparable to Hubble version since infrared can penetrate dust clouds much more efficient. As light travels over the vast distances, it stretches out into the infrared range, which is beyond the visible spectrum for humans. This stretching, known as redshift, is measured by astronomers to determine the age of the object the light originated from. A higher redshift means the light has traveled further, while a lower redshift suggests the object is closer to us. With the JWST observatory, astronomers can effectively see back in time up to 13.5 billion years ago, almost as far back as the estimated age of the universe, which is around 13.7 billion years. Surely, not so long after JWST became operational, it spotted 6 massive ancient galaxies, which astronomers are calling universe breakers because their existence could upend current theories of cosmology. What's really intriguing is that given their supposed young age, these galaxies were expected to be small and underdeveloped. However, these observations have revealed that they are actually as mature as our Milky Way galaxy, even though they are only around 500 to 700 million years old after the Big Bang. But you are here not for this. You might have seen an astounding image of pillars of creation, but where really is that creation starting point? The beginning or the edge of the unknown? One of the 4 main objectives for JWST Observatory is to find the first galaxies that formed in the early universe and to see stars forming planetary systems. The Webb telescope captured an image of a galaxy from the early universe that was formed a mere 235 million years after the Big Bang, making it the oldest galaxy that scientists have ever observed. This particular galaxy has been named Ceres 93316. At a whopping distance of 35 billion light-years away, it's one of 6 ancient galaxies currently under study. While the image of this galaxy may not appear particularly impressive, we finally can put the realization of massiveness of the cosmos into some scientific perspective. We don't really have the map of the universe, cannot even say for certain about its shape, only theories that we slowly but surely begin to prove and comprehend. For example, JWST did a great job capturing some warped galaxies out there. This cluster holds so much star and planetary weight that it literally warps space. And the warped area distorts and magnifies massive objects in the distance. Astronomers call this gravitational lensing, something that was predicted and calculated over 100 years ago by Albert Einstein, but something that we can observe and understand for certain today. So gathering up all the data that we have collected so far, we can understand that a light travels at a fixed speed through the vacuum of space. The deeper astronomers look into the universe, the more distant light they intercept, and thus the farther back in time they see. Thus we can calculate the age of the observable universe. We can strongly confirm now that at this age that we see today, we found only more questions. And what lies beyond remains a complete mystery to us. This was Georgie with Adventures in Space, and I will see you at the next one.